Okay, welcome. Today, I would like to discuss the idea of a function, right? So, from time immemorial, you've seen functions day to day, believe it or not, as you've talked about algebra, right? So, a function will always arise whenever you have one quantity depending on another, right? For example, let's consider a case that you're deeply familiar with, right? Let's consider the area of a circle. Somewhere at some point, hopefully in geometry, someone told you that the area of a circle is area A is equal to pi r squared, right? And you went with this. Um, so one of the things I want you to realize is that depending on what, oops, depending on what value of r you have, your area will be different. For example, if I give you r is equal to 3, then area is equal to 9 pi. If r is equal to 4, then area is equal to 16 pi. So it looks like area will always depend on r, right? And because area is always, a is always going to depend on r, I will go ahead and say that a as an area is a function of r, right? And that makes sense, right? So it means I need an r in order to give you an a, right? That's what that means when you're a function of something is I need something independent, which in our case is r, that would always give me the a. Another example is let's talk about the population of a population in the world. This is a new example, so I'm just going to draw a line. Population in the world at a time t. When you think about time, one of the things that you hopefully know by now is that you can control time. So time has this independence to it, right? So if I asked you for what was the world population in like the 1950s, I was like, hey, what is the population in 1950? I'm writing it like this, population in 1950. You'd probably tell me it was like maybe 2 billion people, right? And now if I asked you, hey, what's the population in 2020? Again, maybe guesstimating, you'll tell me it's 7 billion people. So again, it looks like depending on the time, on the moment in time you're in, you would always give me a uniquely different answer. So in that case, I can also say that, hey, it looks like P, population is always a function of time. So if we just take a break from just thinking about the mathematical implications of this and just think about this as a conversation you're having with friends, this is true, right? Because right now there are 7 billion people, and there's a projection that if, let's say, each of those people had a child, then in the future there should be more people, right? So it depends on the moment in time that you're talking about. And there are so many more examples that I could talk about, but I think this is a fair point for me to just formally define what a function is. Okay. So let's formally define a function. What is a function? If someone keeps telling you, hey, what is a function? I know my F's look weird. I'm going to try to fix them. I was talking about handwriting and look at my F. Okay, so a function, typically we will denote it with F or G or H, is a rule that will assign each element X from some set, let's call that set D for argument's sake. It will assign this element X from some set D to exactly one element. And typically we will call this element f of x in another set. Let's call that set E, right? And then if this is kind of like a pre-calculus, if you had the conversation about domain and codomain or range, this is kind of where that conversation comes from, right? So in our case, set D, the way I've defined it would be my domain, and set E would be my range, right? And then the other thing to notice is that X is my independent variable. Oh, trying to make it fit in there. Let's put it over here, independent variable. And Y is my dependent variable. So I need to cut the video short right here, but go on to the next video and then we shall proceed.